Okay. Today I would like to present my report overview of explainable artificial intelligence. Nowadays, we have saw a fast and widespread adoption of artificial intelligence in our daily life, which contributes to accelerating the shift towards a more algorithmic society. However, even with such unprecedented advancements, a key impediment to the use of AI-based systems is that they often lack transparency. Indeed, the black box nature of these systems allows powerful predictions, but it cannot be directly explained. This issue has triggered a new debate on explainable AI. Explainable AI is a research field that aims to make AI systems results more understandable to humans. In the first part of the report, I'm going to begin with a few general comments concerning the explainable AI, and then discuss in more detail about the methods. Finally, introduce the usage of explainable AI. Scope of explanation can be either local or global, and some methods can be extended to both. In general, a locally explainable method are designed to express the individual feature attributions of the single instance of input data X from the data population X, and a global explainable model provide insight into the decision of model as a whole. It works on an array of inputs to summarize the overall behavior of the black box model as illustrated in red figure. A method of XAI that I'm going to introduce contain LAM, deep lift, sharp values, kernel sharp, and deep sharp. And the overall our goal of LAM is to identify an interpretable model over the interpretable representation that is locally faithful to the classifier. Firstly, we divide the original image picture into different parts called interpretable components, and give the input data perturbation by hiding some interpretable parts of a picture. Then we will get some results, and then the perturbed data samples are weighted by how similar. It's how similar are weighted by how similar they are to original data. And it's the process of lame explanation. And F is a black and pink background. It's mean a black box model's complex decision function. And X is the breadboard. Breadboard red cross its instance be explained, and Z is crosses, these crosses and these circles around X. And G is our learned explanation locally. It illustrated in the feature is dashed line. And finally, vector is a proximity measure between instance Z to X. A link sample instances get a prediction using F and weights them by approximately to the instance being explained. In this feature is by size of crosses and circles. And deep lift. Deep lift was proposed as a recursive prediction explanation method for deep learning. It attributes to each input xi a value that represents effect of that input being set to the reference value as opposed to its original value. This means that for deep lift, the mapping converts binary values into the original inputs, where one indicates that an input takes its original value, and 0 indicates that it takes to reference value. The reference value is our site, is the user site, and represents a typical informative background value for the feature. And this is a deep lift method. It's equation. And finally, a SHAP method. SHAP method is one of additive feature attribution method. SHAP explains prediction of an input X by computing individual feature contribution towards that output prediction. There are three properties. Property 1 is called local accuracy. When approximating the original model F for a specific input X, locally accuracy requires the explanation model to at least match the output of F for the simplified input X0. It means that which this is corresponds to the original X. The second property is missiness. If the simplified input represent feature presence, then missiness requires feature missing in the original input to have no impact. The third property is consistency. Consistency is that if a model change so that some simplified input contribution increased or stays the same regardless of the other input. It means for all inputs that input's attribution should not decrease. It's keep the same. It's called consistency. This is a process of SHAP values computation. And the deep SHAP is combined with deep lift and SHAP values. In this process, we do this transform. And we can combine these two methods. And the kernel SHAP is combine linear Lime and Shapley values. And the left is from incursion of Lime, and this is from SHAP. We combine the two methods by this way. And finally, we compare the computation. We compare the accuracy. In this case, we can see a bigger number of features in this picture A. It means that have 10 input features. A bigger number of features. Kernel SHAP and Shapley sampling are very close to the true value, but when the number of features deduced locally, in picture B, it's just three features. And we can see Shapley sampling starts to deviate obviously from the true value. It's just like a jump. And finally, the change in log odds when masking over 20 random image supports the use of better estimates of SHAP values. In this picture, we can also get the SHAP is the best method to explainable AI. Okay, that's all. Thank you.
Okay, thank you. This is very interesting. So I have a question. How SHAP is applied to image processing? I see.
Lime
case for images. No. This picture, yes, this picture. This slide.
picture,
no need to. Yeah.
Okay.
You have SHAP, right? shape
Yeah.
is applied to 20 random images. How?
Just
Can
like
you repeat this?
just like masking overall. It's masking is just like this, just like a line. We yes, we adding or we hiding, just like we hiding some parts of data or pixels or just yes.
So
We
we are clustering. We are finding clusters in the image, and then do they explain, right? As a kind of
yes,
yes.
about maybe because about clustering knowledge I haven't connected with Feiran. Yes, maybe some problem in this, but in next week I will deal with.
No. How SHAP approach is applied to images? Because on this picture I see the change in log odds when masking over 20 random images supports the use of best estimate of SHAP values. So here SHAP is applied to what? To pictures, right? How SHAP is applied to pictures?
It's just I find in the papers. In these papers, yes, those haven't shown the results that is showing SHAP is the best way to explainable.
Do you understand my question or not very? So I have a very simple question. How SHAP is applied to images? Because I
yes,
see.
Yes. I know this question, but maybe I don't know because I just get the results directly from the paper.
Okay, no problem. Okay, okay. In future, if just answer, you don't know. Okay, you don't. Okay.
Yeah.
Okay. Yeah. Okay. Thank you very much. I think this is very interesting. And can I ask you to add first? Can you go to the very beginning of the slides? You know, one of the first slides, beginning.
First slides, beginning.
Yes. So. Yes, maybe this or four, number four, number four.
Number four.
Yeah. No, little bit below.
Okay.
Six. Yes. So here you say that you want to present these approaches, right? But I want you to add a picture with a list of all possible approaches so that you could directly say that now we present overview of these approaches, but also there exist this number of approaches which we will present later. You understand? Because I remember in the overview paper there was a very good graph picture with the overview of all. Wait. Do you understand what kind of graph I'm talking about, or not very?
Maybe it's just like a XGBoost or coding, a picture about coding. Or
No. Wait 1 second. I will find 1 second.
Maybe I forgot it.
No problem. I will. 1 minute. I need to find. A minute. One more minute, sorry. Okay.
Maybe you can write to me в ВКонтакте.
Yes, I will, but No, I have so much things to do, so I don't want to, wait until some time. Why can Okay, in Vkontakte, please send to me the overview paper, okay, for the XAI. You remember I have sent to you the overview paper.
Yes.
Yes, please send it to me and I will directly show you which graph to add, because the key point is that you say that you want to explain this number of approaches, but people who will listen to you maybe do not know what kind of approaches exist. So you need to show that we explain this, but also there is a big list of other things, so that in future we will also discuss this. It's the first thing. And second thing, I wanted to ask you if it's possible to add one more approach, because actually, you see, Lime is one direction, DLBleef with second direction, and all is related to SHAP is actually third direction. It's not several different directions. SHAP is a kind of general. So if you can,
Yes.
please add one more. Maybe it will be small direction, but anyway, it's very interesting. If you think it's possible in 1 week. If it's not possible, then for now, no need.
I
It's
just
up to
think
you.
I just think for each just to have 14 minutes. So maybe okay, I know.
No. It's a question. I'm asking you if you think that
Another.
in 1 week it's possible or not. If it's not possible, then
Yes, possible. I can.
oh, okay. um, okay, I think this would be very great. Actually, we do not need to limit ourselves to 14 minutes or 15 minutes. We will discuss this with Lean later. So because your presentation is very important, because our colleagues do not have this knowledge. So for them, it will be very interesting to listen to the overview, even rather than to listen some specific results, because they do not have any information. They will be very interested in this direction. So your presentation is very, very important. Maybe we don't need to limit it to 15 minutes. Yes.
Yes.
You should understand that it's very, very interesting content, I think.
Okay.
Okay, and later, I think during the week we can discuss in details about this, not about the presentation, but about these different methods and about what we plan to do next with this, with you. Okay. Okay. Thank you very much. Thank you. It's very great.
Thank you too.
So, who is next?
Next, 下一个同学。
А Фейран сегодня нет? Где Фейран?
Да, у меня вопрос. То, что Зhang Yu спросила, что Фейран и Зhou, они будут или нет, я ответил, что я забыл. Потому что в группах вообще их нет. Ну, как в будущем? Должны пригласить или...
Ошибка. Я могу пригласить.
Да. Ну, Фейран не готов.
А ничего, мы должны с ним обсудить все равно.
Окей.
Это не так.
谁叫一下许飞然？
我叫吧。
И ты могла бы пригласить Фейрана и сообщение в
Да-да-да-да-да.
нашу WeChat-группу. Спасибо, спасибо.
Да,
啊，
学啊，да,
对，
学
你把他俩
просто
叫进来，然后你可以走了。
好，马上。
哎，好的，没事儿。OK，next， 是哪位？
学长是我。
哎，好的。Please show your presentation.
Okay. Can you hear me?
Yes.
Okay. The topic of my report is gradient descent algorithm. In the machine learning algorithm, sometimes it is necessary to construct a loss function for the original model and then optimize the loss function through the optimization algorithm so as to find the optimal parameters and minimize the value of the loss function. Among the optimization algorithms for solving machine learning parameters, the most used is the optimization algorithm based on gradient descent. I summarized it from the following 4 aspects. The first part is the introduction. Gradient descent is to find the shortest path from the top of the mountain to the lowest place at the foot of the mountain. But because of the choice of direction, the lowest point we found may not be the true lowest point, as shown in Figure 1. The direction indicated by the black line is not the real place. So how to find this way? Let's take a look together. The gradient descent method allows us to choose a random direction first, and then choose the steepest direction every time, and we step until the lowest point that can be reached in this direction. In machine learning, 2 gradient descent methods have been developed based on the basic gradient descent method, namely batch gradient descent and stochastic gradient descent. In the second part, I will describe the principle of batch gradient descent and how to use its corresponding algorithm. First, we determine the hypothesis function. Here we choose the hypothesis function in the case of linear regression. For linear regression, the hypothetical function is expressed as h theta x1, x2, and xn is equal to theta 0 plus theta 1 x1 and so on. Theta I is model parameters, xi is n eigenvalues of each sample, and it reduced to h theta is equal to the sum of theta g by xg, where g starts from 0 to n. Then we know the corresponding loss function is g theta. And it's equal to the sum of the squares of h theta xi minus yg divided by 2m, where I starts from 1 to m. In the first step of the BGD method, we need to determine the gradient of the loss function at the current position. For theta I, its gradient expression is a partial derivative of loss function to theta I. I calculate its final expressions as the sum of xg is multiplied by the value of h theta xi minus yg divided by m, where I starts from 1 to m. In the second step, we need to judge that the gradient descent distance of each value in the seed vector is less than epsilon. If it's less than 0, the current seed is the final result. Otherwise, update the seed and reint step 1 until the result is found. The update expression is theta g minus alpha multiply potential derivative of loss function to theta g. Now we start the third part. Batch gradient descent is to find all the dates in a dimension and take average as the step of each gradient descent. Although this is accurate, but it takes a lot of resources to calculate the gradient of all dates in a dimension each time. Also, then there is another idea of the stochastic gradient descent. Each time, only one piece of data in one dimension is randomly taken to find the gradient as the step of gradient descent of this dimension. The formula is as follows. The first one is still potential derivation of loss function to theta I. At this time, only select a sample G to find the gradient, and its expression is like this. Then the corresponding update formula is theta G minus alpha multiply xg multiply the value of each seed xi minus yi. In the last part, I implemented the batch gradient descent and the stochastic gradient descent. I use the batch gradient descent method to calculate the minimum values of Rosenbrock function. Let's take a look at the form of the Rosenbrock function. Fxy is equal to square of 1 minus x. Add the square of 1 minus square of x. Firstly, we set the learning rate alpha to 0.001. Iteration cutoff condition epsilon is 10 to the negative 9th power and set the maximum number of iterations to the 6th power of 10. Secondly, randomly generate an initial point and find its function value in the loop that doesn't exceed the maximum number of iterations. We use the gradient function to get the gradient of the initial point. The function here is calculated manually by myself. Then we use the formula set to subtract alpha and multiply the gradient to get the updated set. Besides, determine whether to continue the iteration. If the absolute value of difference between the update point and the initial spread is less than iteration cutoff condition, that is epsilon, then the update point is a minimum point. Otherwise, we continue to iterate and use the coordinates and function value of the updates point as the initial point for the next iteration. At this time, since we have obtained the gradient for each sample point, it is in line with the idea of batch gradient descent. The final result is shown in Figure 2. We iterated a total of 15 this time and finally we got the extreme point of 0.9996 and 0.9993. The minimum value is Figure 3. Finally, we use the axis three-dimensional 3D library to draw the function image of the three-dimensional coordinate system. Sorry. The blue part in the figure and the extreme points found the red dots in the figure 3. And the second method to find the minimum value of a function is stochastic gradient descent. Like the first method, let's make sure alpha and epsilon get the gradient of the initial point first. We have to choose the next point from the sample points randomly generated in advance and determine the iteration cutoff condition. If the minimum points hasn't been found, then we update the gradient of this point. And the final result is shown in Figure 4 and Figure 5. That's the end of my sharing. Thanks for listening. Hello?
Hello？
It's ending.
那个你能给我说一下你做的这是什么东西吗？因为我不学这个，不太懂。
就是一个最优化的那种方法然后
这个
对，然后我
这个和之前奥纳斯给你的题目有什么相关性吗？
那个老师给我的题目里边就要学习这个算法，它就是梯度下降
梯度下降。
然后这个是里面的2个分支。
对，你们最近的课程里面有这个梯度下降是吗？
对，有。
但做的幻灯片很漂亮。然后奥纳斯现在忙可能接电话吧。他说他刚跟我说觉得你做这个特别就是讲的特别好。
谢谢。
然后就是这个好像因为和现在做的东西没有看出来这个特别直接的关联。不过你说如果用的这个方法里面需要用到梯度下降的话，做就很不错。
就是那个我要学的东西里面是有梯度下降这个方法的，然后我就把这个底下的分支学了一下，然后最近刚好有那个就是最优化的课程里面需要那个就是要求那个函数的2元函数的那个最小值，然后我就刚好用这个方法去做了。
好的。
Hello.
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 Yeah. A very good presentation. Thank you very much. I wanted to ask. So, how about your progress now? What have you studied and what you plan to do next?
I want to do the linear regression to depth and the decision tree.
Okay, but when you plan to finish your education, because your direction is explainable AI, right?
Yeah.
So at some point you need to start working in this direction because time is limited, right? soon it will be the end of first semester, and I was planning that the end of first semester should be the end of kind of education. After this, you need to start working on specific projects because time is limited. So when you plan to finish your education, I'm not asking you to finish as soon as possible, but how can you estimate when you want to finish? You need to finish basic education for machine learning and data science. So when? When?
Yeah, I about 1 month later.
Okay. Okay, but I suggest not later than the end of December. Okay.
Oh,
So
okay.
so maybe you should push. I know that you have a lot of lectures now and
Yeah.
classes, but I suggest you to push this direction because it's kind of your scientific work, and it will be very important for your future, for the job, or for for PhD, for research and development, for these things, for company. This is very important. So I suggest you to finish it as soon as possible, so that we could start work on real projects. But I want to ask you something. When do you think, you know, because education is not only in your scientific plan, there are two phases. First is basic education, like what you're doing now. You're trying to learn what is machine learning, right? And second is scientific work, when you already know something and you doing projects. But the second part of education is actually to learn about your research topic. Your research topic is not in general machine learning. Your research topic is explainable AI. So at some point you need to start learning explainable AI. So and the easiest way to start learning explainable AI is to help and to work together with UE. Maybe I'm mispronouncing her name, but is to help UE to do the overview for the XAI. By helping her, you can learn, and then she can also start doing projects, and you can easily learn explainable AI with her together by consulting with her and chatting and so on. So my question is, when do you think you can start learning explainable AI? So it means when you finish the basic course for machine learning and then start learning explainable AI together with UE.
So 1.5 months, because I watched the course and online course and do the homework. You given me the link. And I completed the 80%.
Okay. So but let's make in 1 month, okay? So after 1 month, I hope you can finish your basic basic education. Later you can also do it, yes, but maybe we need to go. Let's see, but maybe we need to go a little bit faster. So I want you to, after 1 month, to start helping UE with the overview. You know what I mean? You understand, right?
Yeah.
Yes?
Yeah.
Она понимает, о чем я? И ты понимаешь? Я не знаю.
你明白他刚说的吗？
就是老师说让我跟那个张雨艺学姐，就是1个月之后，1个月之后就是后边有点稍微不是很明白。
就是他说你这个东西，就是你学压力也挺大，但是这个东西得尽快结束，然后得和张宇一起，然后我给你建议啊，就是你这样吧，他给你的进度呢，其实是已经比较慢的了，所以无论如何他说的都得做到，你就这样去回复他，然后尽量和张宇一商量着把这个尽快做完吧，就是学习完。
好，
你不用讨价还价，什么半个月、一个月、一个半月什么的，尽快
哦哦，
那你跟他
Э,
说，окей,
Она понимает, да, что я
да,
я имею в
да,
виду?
она понимает.
Okay, 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 okay. But maybe we will see, but maybe during the seminar at 15th of November, this topic maybe is it's kind of it's a little bit more educational than scientific. So maybe it's good for the report, but maybe not so good for this big seminar. So you can keep this presentation. And if because time is limited, we have only maybe 3 or 4 hours, not only for us, right, as the last time, right, but we have also several participants from other universities. So maybe we can think what you could present next time in 1 month. After 1 month, we will have the same participants, maybe. So same universities, I hope, and then you could present something there. But for example, for the next presentation, you should consult me what to present. Okay. Okay. Hello.
Hello，
You
那个
understand? You understand what I mean?
，sorry，学长，那个教授刚刚说啥？我没太听明白。
他刚说是他刚说啥？我刚有事没听，你们谁听了？
刚才应该老师说的是，就是因为下周有别的学校来，然后他们也要报告，然后这个也只有3-4小时，然后说这个虽然讲这个，马瑞敏做的这个很适合报告，但是可能不适合那个representation，然后所以就可能下周就不太需要，可能到时候看情况，
对，
应该是不需要讲。
你说的真委婉，对，好像是这样，是。
Okay, thank you.
Yeah. So because I want you to present something that our colleagues from other universities do not know. So I hope you and also other guys from the Explainable AI team will write to me after this seminar, and we will think what to present. But it does not mean that you should stop your education, right? Your education is still very important, and this kind of seminar is a good opportunity for us to do now. Yes, now it's a good opportunity for us to study some overviews and to present these overviews to the other guys. Yes, because I think you almost finish your machine learning education, or you're somewhere in the middle. So you now can already start thinking about what you will be doing next, what kind of topic, and the topic is explainable AI. So, but before you start kind of topic, you need to do some overview. You need to understand what exists in explainable AI. And thank you very much to the UE. She already have started to help us in this direction, but you need to help her later. I mean, not only you, but the whole team for explainable AI. You need to focus together for this overview. And when you finish with some, when we finish some stage of overview, we can start to do some specific scientific project. But anyway, everything is step by step, right? So far you're doing very good, and I'm very thankful. for your presentation today. I see that you understand gradient descent, but actually, I have a comment for you. Now the so-called evolutionary algorithms beginning to take the advantage of gradient descent. You can Google what is evolutionary algorithms. Evolutionary algorithms is a kind of method for black box optimization. It is a little bit more advanced than gradient descent. And now people and it was developed for the operations research, for scheduling problems, for large scale optimization problems, for combinatorial optimization problems, for things like this. But now people from machine learning also start to use it for very complicated tasks, because this algorithm sometimes can converge much faster and give better results than gradient descent. So if you're interested in this, you can briefly read about this. I'm just giving you, it's not, you will not need this in your direction in your future research, but anyway, if you have time, just watch at least several videos about this. It's also very interesting, so that you have this knowledge. But you will not need this. You will not need this, of course. Okay. Thank you very much. Maybe next one.
好的，下一个同学。下一个谁啊？刘秀秀。刘秀秀。刘秀秀不在是吗？
Hello. Hello.
Hello. Hello. Нас.
Я тут.
Почему никто не отвечает?
Я не знаю.
刘秀秀不在是不是？
Можно следующий.
是的，就好像没有看到在房间里。
行，我们下一个吧，因为刘秀家停电了。
哦，好的。
У нас следующая
Да.
девушка, его интернет дома не работает пока, поэтому это referencing AI.
Как интернет не работает? Китай — это страна 5G. Как не работает интернет?
Ну, случайно.
Зачем так глупости?
90. Ну, она будет, потом.
Окей. Ничего.
Hello,
Professor. Hello.
Hello.
Can you hear me? Hello, Professor.
Yes. Hello.
Okay. Hello, everyone. My name is Sun Qiushi, a PhD student in direction multiple agent reinforcement learning.
Sun Qiushi, wait. Please write PhD student, okay?
Oh, okay.
Okay. Thank you. Okay.
Okay. And there are 6 parts of my representation. And first, I will introduce online courses. Then I have finished all the online courses of single agent reinforcement learning. And I have did some practical programs with classical reinforcement algorithms. So this part I will skip. And next is skills in deep learning. Here are some tools and libraries that I have used. I have learned and used during my in my project. First, TensorFlow is an open source framework of deep learning, and Sina is a library that optimizing and evaluating mathematical expressions. And next is RE. is a reinforcement learning library in Python, which is also very useful. And last on these two, Google Drive and Google Colab is a platform which make it possible to train the reinforcement learning models that using Google Server. And the next is algorithms that I did practical programs. This is all classical methods in reinforcement learning, and I almost finished all of the practice of this. And last month I did the algorithm which is a policy based a critical actor critical with short by AC, and its improvement is RISC, and also a method which both use the value based and the policy based method called DDPG, and then I will introduce them. First is actor critic. Here is the method which combine the policy gradient method and the function approximation method. And here we can see the objective function. The first, this part, this policy structure is known as actor because it's used to select actions. And it's based on policy gradient. It's very easy to select the property actions in continuous action space. And this part, you can see it's Q value function minus our baseline value function, or minus our baseline. This part is known as critic because it can criticize the action that is selected by the actor, and then I will explain the meaning of each part of this formula. Here, the Q value function, this means how good the action we take from the current state S. And this, and this our baseline. This is the average return when other agent face the this is the environment. And here, the Q value function minus our baseline. This is also called the advantage function, which reflects how good the action we have taken compared to other candidates. And then I will introduce the structure of AC algorithm like this. We can see this is the policy structure, and this is the policy. This is the policy network that we call the actor, and this is the value network that we call the critic. In policy network, we choose actions that will interact with the environment. Then we can get our reward and the transition state. And then with this, we can get the TD error. And with this error, we can improve our policy. And this is a loop. And with several loops, we can get the optimal policy. And compare with the totally policy gradient method, because here we have a critic, we can evaluate our policy, so it's more faster than the simple policy gradient method. And next is the improvement of actor critic here. As in the corners, advantage actor critic, which short for A3C. And what's the difference between this and the previous AC algorithm? Here I will introduce A3C is based on AC algorithm, and from the above we can obtain that the advantage function A equals to Q value function minus baseline, and Q value function can write like this. And if we do not consider the action formula, we can get our advantage function like this. This is also one step forward because there's a critic each time they only go one step forward. And in A3C, we use n-step sampling to, yes, so this way the converge maybe not very faster, it's slow because it's only one step. And in A3C, in A3C we use n-step sampling, so it will make the convergence faster. And another improvement is the part of loss function. We also add the input of policy pi here to make the converge faster. And another improvement is asynchronous. This word is like its meaning. If one pair of actor and critic is not as fast as we want, then in training the models, then we can use multiple pair of actor critic. It's like we run our program with multiple trading. As we can see here, the structure, we have the global network, and then we have several independent subnetworks, which like a worker. When the first step, when we run the model, each worker here, they copy parameters from the global network, and the second different worker here intersect with the environment, and the third, they can get their gradient, and the fourth, all the worker give back their gradient to the policy network, and last, the global network uses this gradient to update the parameters. We can see in AT algorithm we only have one actor and one critic, so it's slow. But here we have several, so the time is much faster. So the converge is much faster. And here is the structure of A3C. The actor using policy pi to intersect with the environment, and gathering samples. We use these samples to train our Q value function. Is this our critic? And we fix the parameters, and then we get back to train our actor. That to make the outcome of the actor action, it can obtain the maximum Q value in Q network. And with this, we can get a new actor pi, which is better than the previous pi. And yes, here is an example. I also used the very classical environment pendulum. And here we can see the A3C agent can learn maybe less than 100 episode it can converge. And next, I will introduce another methods which combines value-based methods and policy-based methods is DDPG, Deep Deterministic Policy Gradient. It combines actor critic and DQN. Deep means DQN, and the policy gradient here means actor critic. And the deterministic here, I will explain what it means. We know that we get stochastic policy using policy gradient method like this. The output is a distribution of probability of the actions, and get a deterministic policy using DQN. The output is particular actions. When we computing the first stochastic gradient, it requires more samples because we both use the state and action space. And deterministic gradient, they only use the state space. So in DQN action, in DQN action was selected as this function. We select action which can maximize the Q value. But what we talked about is not particularly for continuous action space. So here we use the deterministic policy as this function. And the deterministic policy gradient it may not explore the full state and action space. To overcome this, here we introduce the noise process, and like here it's like a random action that that we will take. It's just like the epsilon gradient approach in DQN, and we want to maximize the reward of Q, which means our Q value that received over the simple mini batch. So the gradient is given like this. Here is the G function. G function is also our objective function, which means the expected Q value that when state S is according to the distribution rule, and and we will get the maximal expected reward as long as we update the model parameters following the gradient formula above. And here is the structure of DDPG. We can see it's the same with the DQN methods. That here we also have two networks, the mean network and the target network. And in each network, we have a pair of actor and critic. Our object is to maximize the G value here. Yes, the G function, and to minimize the loss function, which calculated by this mean network and the target network. And you can see we update the parameters of Q network here. Follows the gradient of policy mu, follows this. And what we want to get is the optimal policy mu. And with this optimal policy, we can get the optimal reward. And this is what we want to do. And here is example, also pendulum example. And we can see the blue line is our return and the orange is our average return. We can see this return converge about less than 20 episodes. It's much more faster than A3C. So because the DDPG is the combine of value-based method and quality-based method, so it's much faster. And here is the papers I have read. And then I will introduce the project I did last month. My project is about the resource management problem. This in system and networking often manifest as difficult online decision making tasks where appropriate solution depend on the understanding of the workload and environment. And here we consider to building a system that learn to manage resources directly from the experience. In previous work, only one agent environment is considered. And here we consider the environment with multiple agents and try to use deeper reinforcement learning methods to solve this problem. Here we can see is the environment. The different color with the different color within image means different jobs, and the x-axis is resource, y-axis is time. For example, the green one means a job which need 1 unit of CPU and 1 unit of memory for one time step. And the right we can see is need two units of CPU for 3 times and 1 unit of memory for 3 times step. And the job slot is here. The cluster is a job that are already scheduling, and the job slot in job slot is a job that are waiting for scheduled, and the backlog is the job that out of the job slot, because the job slot is limited. There may be just 10 job slots, and the job arrive at the cluster with Poisson distribution. If there are more jobs, so they will wait at the backlog. And in job slope, we can know the resource and the time steps the job need. And in backlog, we only have the number of the job. And here is the reward. Job slow down. Like this. And for the program, we only use one agent environment. And for the method, we use policy gradient method with DNN. And here we can see we compared this with the previous we can compare this method with other method. And here we can see the result like this.
This is your environment, right?
Mm-hmm.
And
No,
what
it's
kind
not
of
my
other-
environment. I think even his script just the element the paper is it's also one agent environment. It's not multiple.
Okay. No, not environment. Sorry. The simulation is yours, right? This is yours. it's
Yes,
not from
simulation
the
is
paper.
mine.
Okay,
It takes
it's very good.
yes, it takes many hours to train it because the reinforcement
Yeah.
learning algorithms they need much more resource than traditional machine learning.
Yeah, I know. But
Yes.
reinforcement learning has other advantage.
Yes, we
this
do not need to know the environment advantage.
Yes, we do not
Yes.
need to know anything. It's a first step for the general AI. For example, you can consider classical machine learning methods, even deep learning methods, as a kind of as a phone, as a simple phone which can call. So you for example, you buy a phone just in order to call. So that's a simple that's a classical machine learning methods, even deep learning methods. Maybe it's a good phone because it's deep learning, right? But yes, sometimes this phone can go to internet. It can run some different apps. It can do some face recognition. Also, it's a deep learning. But when you start, when you buy a phone and you ask him to do something, for example, you ask him, phone, please learn Spanish and start to talk with me in Spanish. Or phone, please, not phone, maybe you can ask a robot, please learn how to drive and then be my driver. Just deep neural network, deep learning algorithms cannot handle this kind of things. But people think that reinforcement learning will be able to do this in, I don't know, maybe 10 years or 20 years or later. But
Yes.
it's a kind of it's approach for general AI, because you give a task, you define a reward directly by giving a task to a robot, and then he learns how to do it. He learns
Yes.
how to do it by himself. Then you change a task, and then he learns by himself how to do it. So in this sense, this is very promising direction. And of course, our project is not cannot cover the whole potential of reinforcement learning, but anyway, this is very very important topic anyway.
Yes.
Okay, I want to ask you, what is Tetris, ASJF, and random? What is this kind of algorithms?
It's classical algorithm that used in cluster scheduling.
Okay.
Yes.
It's very good. Do you have other two slides? absolute plan.
No,
Okay.
because for this part, I still have some things that I need to confirm with the event. So I just made about the 3 slides of this project, and I think I need to make more after I confirm it with the event. Maybe I
okay.
think tomorrow, or maybe we can. Yes, we can have a meeting in our VK group that with Ivan and Anna, I think.
Yes, okay.
Yes.
This is very good, actually. Your presentation is very good, and actually, what I want to say to you that you present 2 things. You present first the overview of algorithms, and also you present the results for the projects. And I think everyone will be very interested in this during the seminar. And what I want you to and what I want you to ask, and what I want directly to ask what other guys from reinforcement team, other guys from reinforcement here, are you here?
Yes, yes.
Yes.
Here.
So, Suntsushi, could you please open the slide with the graph for algorithms?
You mean
graph, one of
graph?
the first. Yeah. So, Suntsushi, I want you to focus. So I think that from
You mean
your
this algorithms that in Colab?
no.
Oh.
No need to open Colab. No. Colab, it's okay. That's very great. But yeah, the presentation. So I want you to focus directly on the slides and results for projects. But I want other guys from the team for reinforcement learning to help you to make the first part of your presentation a really good overview for reinforcement learning.
Oh,
So,
okay.
yeah, so can you open one of the first slides? Yeah.
This.
Yes, the graph.
The graph. Here.
Yes, this one. So, guys from the reinforcement learning team, we have so many guys in reinforcement learning team. So, I want you to help Suntsushi to update the overview part of this presentation. You can see that he did not add here all of the algorithms that he already studied and you have studied together. So I want you to update this graph, and I want you to Suntsushi, can you go below? I remember you have presented before the explanations or some slides for SARSA, for DQN, and for all other algorithms which were listed in this graph. So I want to ask you to add all these slides and presentations here to this one presentation.
Yes, but it will be very long.
I know, but we will think how to do it, because from my understanding, from my point of view, overview presentation is very good, very important for all of the people who will participate in the conference, in the seminar, because for them is if they did not work on reinforcement learning, they will be very happy to listen. So this kind of presentation is very important for them, and I hope that next month they will also prepare some overview presentations for their directions, and then we will be able to fastly learn what about their direction. So it's a kind of very good, very important exchange of knowledge, you know. So I know that you have all the slides. I know that you have description for other algorithms, and I want you to add the slides. I want you, but Suntsushi, you should not do it. You should focus on projects. I want other guys to help to work on your on your presentation, to add the description of the algorithms and also at the end of the description of each algorithm to add the simulation results for it, because I remember that you were using different environments, different classical problems to test the algorithm. So I want you to add this as well, because it's important for people to see how it can be applied. Okay.
Okay.
Yeah, Sun-Sushi, but you should not do it. Maybe you could just help guys to give your presentation to maybe if you have some simulation results to share to them, or share your old presentation, and then guys will help you to compose all the slides.
Okay.
It's okay. Maybe if you're a little bit tired to do very long presentations, so maybe other guys could help you to do it. We can think about this. It's not a problem. Okay.
Okay.
And for the project, I want you to ask, because now what you do is you show how you implement the existing algorithm, but
Yes.
you need to show what we plan to do next and how, because our aim is large scale scheduling, right? So
Yes.
we need to provide some ideas for how we plan to do large scale scheduling, and explain why it is important. Why? Because for reinforcement learning, large scale is a challenge. Large state space, large action space, and big number of agents. This is a challenge that we want to solve, and that's very interesting. So let's please think about this. I think we have already discussed this things that we plan to do for this paper. If you have a specific question, we can discuss later or at Tuesday.
Okay.
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 Thank you very much. And other guys, do you understand what you need to do?
Yes,
Yes.
we know.
Okay. I think you do not need to create new slides, because you already have all the description of SARS and DQN. Just please add it here and add the pictures of your simulation results. Okay.
Okay.
Okay. Okay. Okay. Sun-Sushi, do you have any questions?
I have a question. If we have all this algorithm together for one class, and should we present this, or it's just record?
No. I want you or other guys from the team to present this on next Sunday, of course.
So all this together.
Yes.
Oh, I think it will maybe take 1 hour for.
We will think how to make it for half an hour. So
Oh, okay.
I can say like this: for overview, we can have half an hour. For project presentation or some paper related work, 15 minutes, and in details. You understand? So actually, it can be divided. So there will be a lot of participants. So we can, at the beginning of each session, for example, reinforcement learning session, we can start with overview, yes, and then present some projects details. So do you understand?
Oh, yes, I understand.
Yeah. So it's not, and it's up to you what you want to present. If you want to present both, that's great. If you want to present only project details, also great. It's okay. It's okay.
Okay.
Because a lot of there will be a lot of professors from China, from different universities. Also, my friends from the St. Petersburg State University, and also some professors from Europe as well, and maybe even from our Russian friends, professors from USA. And they are our friends, no problem, Russian guys. They just work there. So It's a kind of I think it's very important so that we start communication and we show our potential, because anyway later on we need to find some joint projects with them as well. We need to maybe publish some papers with them as well. We need to the simplest thing is that you will need to defend PhD thesis. So who will be in the council? We need to create a council. People need to know that you are good at it. So and they need to know it as early as possible so that they will agree to be your kind of reviewer for the PhD thesis, right? So all this is it's very important now for us.
Yes.
Okay, so
Next.
okay, thank you very much.
Okay, thank you.
Okay, thank you.
I have a question to the other guys from reinforcement learning team. I have asked you also to do some short overview of the real world applications and maybe some interesting environments in reinforcement learning. Did you manage to look at it at least? At the references that I have sent? Hello?
Yeah, we do.
So I want to ask you to first thing is to compose the overview of algorithms. Yes. I will repeat again. You do not need to create new slides. You just need to combine the slides that you have, all of you have, that Sun Sushi have, and Sun Sushi has, and his simulation results. But what I want you to do new is that you need to add 1 or 2 slides as a kind of introduction. What is reinforcement learning? And in order to do it good, maybe you need to look at and consult with UE from the Explainable AI team, because I think what she presented is very clear and interesting to look. So you need some introduction. What is reinforcement learning? What is it? And only after you present algorithms. Okay? And and maybe after you present what is reinforcement learning, you need to present 1 or 2 slides with real world applications of reinforcement learning. The thing that I asked you. Then it will be a very cool and very complete overview of reinforcement learning. I think this will be very great, very, very great.
Yeah.
Okay.
Okay.
So please, since what I was telling you very complicated, can you please repeat what you need or can do? Could you please repeat? Or
I think I'm ready for my report about the overview of applications of reinforcement learning. Do you want to see it?
Инь, можешь их попросить повторить, что они должны сделать
谁下一
до
个？
15 числа?
I am.
李琼吗
Yeah.
Okay. She is next. 李琼。
Нет, Инь, могут они повторить? Я им долго говорил, что они должны сделать. Они могут повторить, сказать, что они должны сделать? Я боюсь, они не понимают.
就是这个乔安学习的同学们，刚才老师说的话，你们都听懂了吗？
我们听懂了，而且我觉得，
然后给他
我
复述一下。
们做的就是这个。
就是复述一下，就是他说的事情，听懂了，复述一下。你们谁复述一下？
Professor, you mean we need to make a overview of to introduce reinforcement learning in first slide to help Sun Qiu, yeah, and we need to show the after that we need to show the algorithm, but I don't know what algorithm I need to show.
all that you have studied. You remember
Okay.
you were presenting me all algorithms, SARSA, DQN, and you were presenting me some simple simulation, right, for it. So
Okay. You mean you mean island algorithm or 春秋时人的 algorithm?
So this is the overview of reinforcement learning. It means that all algorithms that you have learned together should be in this presentation.
Okay, I know.
So you should take slides from, you use your slides, his slides, everyone else's slides, and add simulation slides, because you were doing in online course, you were doing some Python simulation. Yes.
I know. You mean we should to show our team learning progress and merge our slide. Yeah.
Yes, but you should not present it as learning progress anymore. This is
Okay.
overview for reinforcement learning. So you show that in the reinforcement learning there is this core algorithm such as SARSA, DQN, DDQN,
Salsa Lambda,
DDPG, and so on, Actor Critic, and this is the description of these algorithms, and after the description of these algorithms, these are the simulation results that we have presented. This is the environment that we have used for simulation, and so on. So it's a kind of overview. Yeah, it's very, very important for you and for the other guys as well.
Okay. Thank you.
Because all these people that will listen to you, they in future can be your reviewers, the co-authors, and so on, and cooperation. So it's important to show your strength, to show your power, because your power is what is your knowledge, right?
Yeah.
Your power is your knowledge. It's everywhere like this. Okay. So thank you very much. Can you start? So you wanted to share some applications, right? What you have prepared. Yeah.
哎，怎么突然这么安静啊？
那个学长，
喂
Hello, could you see my screen?
，yes，
Yes.
Okay. Hello everyone, my report is overview for applications of reinforcement learning. And I chose 3 parts of application for application of reinforcement learning, healthcare, natural language processing, and transportation. And my group chose another part. First, introduction of reinforcement learning. Reinforcement learning is defined as a machine learning method that is concerned with how soft agents should take actions in environment. Reinforcement learning is a part of the deep learning method that helps you to maximize some portion of the cumulative reward. These neural networks learning methods help you to learn how to attain a complex objective or maximize a specific dimension over many steps. On the right is how reinforcement learning works. In this case, cat is an agent that is exposed to the environment. In this case, is your house. An example of the state could be your cat sitting, and you use a specific word for cat to walk. Our agent reacted by performing an action transition from one state to another state. For example, cat goes from sitting to walking. The reaction of an agent is an action, and the policy is a method of selecting an action given a state in expectation of better outcomes. After the transition, they may get a reward or penalty in return. And the next is about reinforcement learning problem and different from the other paradigms. The problem is agent interacts with environment, executed an action based on its state and each step, and receives a reward from environment. Want to find an optimal policy start to achieve maximize cumulative reward in the long run. Is different from the other paradigms. First is no supervision on long-term reward, only immediate feedback, and the feedback is often delayed, and sequential decision, and agent's action affect subsequent data received. And this is the risk of RL. RL has success stories like AlphaGo and Altar Games use DQN and robotics, and they have more applications. For example, transportation, recommendation system, industrial control, and education. Next part is about reinforcement learning in healthcare. Omar Gottesman et al. Provide guidelines for reinforcement learning for decision about patient treatment. For example, faced with a patient with sepsis, the intensivist must decide if and when to initiate and adjust treatment, such as antibiotics, intravenous fluid, basal pressure agent, and machine mechanical ventilation. On the right is a model of sequential decision-making task to perform sequential decision-making, such as for species management. Treatment effect estimation must be solved at a great scale. Every possible combination of interventions could be considered to find an optimal treatment policy. The diagram shows the scale of such a problem with only 3 distance decisions. Blue and red people denote positive and negative outcomes. Next is about medical imagination report generations. Christy Wiley et al. In hybrid retrieval generation reinforcement agent for medical image report generation proposed a novel hybrid retrieval generation reinforcement agent, which reconciles traditional retrieval-based approaches populated with human prior knowledge with model learning-based approaches to achieve structured, robust, and derived report generation. The model achieves the high detection accuracy of medical abnormal terms and improves the performance of human evaluation. The figure on the right is an example of a real report and a generated report. The highlighted phrase is a medical anatomy term. Next is about natural language procedure. Many natural language processing tasks, including generations, language grounding, receiving information extraction, conference resolution, and dialogue, can be formulated as deep reinforcement learning problems. The RA method have gained significantly more attention in NLP in recent years because many NLP tasks can be formulated as DRN problems that involve incremental decision-making, DRL method could easily combine embedding-based representation learning with reasoning and optimize for a variety of non-differentiable rewards. The first one is about captaining. In deep reinforcement learning based imagine captaining with embedding reward, Zhu Ren et al. Introduce a novel decision-making framework for imagine captaining. They utilize a policy network and a value network to jointly determine the next best word at each time step. The policy network, which provides the confidence of predicting the next word according to current state, serves as a local guidelines. The value network, evaluates the reward value of all possible extensions of the current state, serves as a global and look-ahead guidance. Such value network adjusts the goal of predicting the correct words toward the goal of generic captions that are similar to ground truth capture. This framework is able to include the good words that are with low probability to be joined by using the policy network alone. And the figure shows an example to illustrate the proposed framework. During our look at inference prediction, we can utilize a policy network and a value network to collaboratively predict the word for each time step. The policy network provides an action prediction that locally predicts the next word according to the current state. The value network provides a reward prediction that globally evaluated all possible extension of the current state. And here is a correlative result of our method and the supervised learning baseline. In the first three columns, our method generates better captions than SLGT standards for ground truth caption. And the next is about dialogue. BD et al. Have presented an end-to-end differentiable dialogue agent for multi-information access in end-to-end reinforcement learning of dialogue agent for information access. All components of the agent are trained using reinforcement learning from user feedback by optimizing a modified version of the episodic reinforcement objective, showing that starting from an imitation learning phase where the agent learns to mimic rule-based belief tracks and policy, the agent can successfully improve on its own through reinforcement learning. The gain performance is especially high when the noise is user input is high. In this work, they present KB InfoBot, a dialogue agent that identifies entitled of interest to the user from a knowledge base by interactively asking for attributes of the entitled, which helps constrain the search. Such an agent found application in interactive search setting. On the right, the figure shows a dialogue example between a user searching for a movie and the proposed KB InfoBot. Next part is about transportation. The smart transportation system have three parts: the smart travelers, the smart infrastructure, and the smart vehicle. The smart travelers from drive along to ride share, and smart infrastructure from independent system to cooperative vehicle highway system, and smart vehicles from human driver to autonomous driving. Next part is about ride-share platform. The first is order dispatching. We can match an available driver to a passenger and revenue generating. And next is driving reposition. Volunteering move either driver to a different location and no revenue generating, but for better match in the future. Third is driver's distribution. Driver location change after decisions are executed and trips are completed. Mainly at all report on efficient ride-sharing order dispatching with mean field multi-agent reinforcement learning. In this part, they use MARL to propose a solution to the problem of how to effectively and efficiently send users travel requests to the right drivers in the ride-sharing system. This solution can reduce the peak time of supply and demand gap and reduce traffic congestions. Next part is about traffic single control. If we want improving the efficiency of the traffic lights, improving the efficiency of traffic lights is key to reducing traffic congestion. Some modern traffic light control system utilize the actuated logic. Such system allow basic event rules to the programmed by a trained traffic engineer with an understanding of local traffic dynamics. However, the inflexible logic in this system cannot adapt to changing environment and optimize control policies. In the paper Reinforcement Learning for Adaptive Traffic Signal Control, Jeffrey Jilic and MS candidate mentioned the effort to use reinforcement learning, especially Q-learning algorithm, to dynamically optimize traffic lights and standard four-way intersections. The decision process is outlined in right figure. Every time the traffic light is about to enter a new phase, the control agent must first detect the state of the environment. With this perception of the state, the agent must select some actions and the next decision point, depending on the quality of new state. Where quality is defined quantitative by an objective function, the control agent is either punished or rewarded. The control agent initially explores a wide range of states and actions. Eventually, the agent learns the best action for any given state and picks the best action with a high likelihood. And the next is conclusion. This report we talk about the real-world applications of reinforcement learning. We look at the various applications of reinforcement learning in the real world. Also, reinforcement learning is still a smart community and is not used in the majority of companies. But gradually, the benefits of the reinforcement learning have become prominent and will surely become more mainstream in the near future. And the end. Thank you.
Okay, thank you very much. Actually, very interesting, very long presentation. I want to ask you, first, did you use all links that I have sent to you? For example, I did not find information about trading and in financial markets. Are you sure you used all links or not?
I choose some contents I need.
Okay. Okay, what is my suggestion? So first thing is that you should combine this presentation with the presentation of algorithms, and how to say, you should start with what is reinforcement learning, and then what are the applications, and then algorithms. But for applications, maybe we do not have so much time. So, for example, if you open slide 3, you have so many text on this slide. So, can you open slide 3? Slide 3. Yes. I see that in here you have so many text. So I suggest you to reduce the text, because in presentations you do not usually present text. You present some key points, like you understand, some key points. Not and for the description of each application, please do not use so much text, and maybe use 1 or maximum 2 minutes to introduce the application. So what you need to do is you just need to say, so there is an application, for example, for robotics. I did not see, by the way, I did not see application for robotics. It's very important now.
Yeah, but my group have chose this part about robot.
So sorry, what do you mean? Who?
My group chose the part of about robot.
Who your friend, or I don't understand.
My groups.
I choose the robot.
Okay.
And yeah.
Okay, sorry, I understand. Okay, so I suggest you to combine into one presentation all the things, okay? And for each application, no need too much text and no need too much time. Maybe 2 minutes for one application.
Okay.
Because
okay.
But listen to me. What you need to say? First, you need to say what is the application, meaning that, for example, robots, right? So we want to control robots automatically so that they learn how to walk by themselves. They learn how to take items and take items from one place to another, and they are learning by themselves, something like this. And second is why you need reinforcement learning for this. Why means that because reinforcement learning is good for robots, because it is adaptive, because we can add this algorithm to any kind of robot, and then this robot can learn by himself, and any kind of robot can learn by himself in any kind of environment or even in the real world. Yes, so this is why. Yes, and then how? The question is how. Is this a little bit more complicated? So, for example, for the case of robots, how is related to the question of the model of reinforcement learning. The model of reinforcement learning is first the agent, second the state, third the action, and the last one is the reward. So for the case of robot, the agent is the robot, right? And the state, or the state of the world for the robot, is his computer vision. So the state is the picture, actually. The picture of what he sees and what are the position of his body, of his hands. It is the state for the robot, the state space. and the action space is how to move his hands, and the reward is what is happening with the item that he wants to move. You know, if the item, if he drops the item or crashes the item, then reward is negative. Yeah, so you could use this kind of analogy. But of course, in the description of some applications, such as trading, you could read only maybe, I don't know, 10 sentences, half-page text, because when I sent you the link, there was a description about the company that uses reinforcement learning for high-frequency trading on financial market. But of course, they cannot share how they do it. It's a classified information, closed information. So you, even if you don't know, you can imagine how they do it. So you can say that you need to add the source of information, such as this application I found in this website, or this application I have found in this paper, and there it is written that they use it for trading. And I think that for trading, the state is, for example, the currency, the value of the currency, or for exchange course of yuan and US dollar, for example, or yuan ruble. And what they do is they decide whether to buy or sell currency, depending on this trading. You understand? So you should give this kind of simple overview, because you don't have time now, and you don't have strength or even information how it is applied directly. So, but just giving a simple introduction is already very great for everyone, for you as well. So I want you together to cover as much as topics as possible, but no need too much details.
Okay.
Just remember the most important thing. What is the object where reinforcement learning is applied? Then why it is applied, because it's important, and how it is applied, means who is the agent, or who are the agents, what is the state space, what is the action space, and what is the reward. Then everyone would be very happy. But do not forget for each slide to add where this information comes from, like a paper or a link or a website. That's very important, because people will, if people are interested, they will directly look, and they will be very happy to know this. But I understand that you did not cover all applications, so I ask you to look again at the slides, to list all applications from them, and send to the joint group, and ask what you should add, because of course I cannot ask you to work too much, because yes, but at least I could tell you what are the most important things to add. For example, robots are very important, and trading is very important as well. Okay. Thank you very much. And please combine this presentation to the presentation of Sun Tzu Shi, so that it will be one file, so that you can show it directly. Okay. Or think how to do it better. Okay. Thank you very much. So, and by the way, how about your how about your online courses and so on? Just in words, can you say?
Online course. I finished my online course, but I still have some problem about understanding the algorithm. So I plan to start a new online courses. It may more detailed about the algorithm.
Do you know which online course you want to start?
It's a I can show you. David Silver.
It's in English, yes, or in Chinese?
This one.
It's English online course or in Chinese?
English.
Please send me the link. I need to check. I don't know, but I need to check.
I can find it. Maybe wait a minute. I can show you. This course.
But you have translation, right? Oh, it's very good. Okay, but anyway, but do you have a Python? Do you need to solve some Python tasks here, or only watch video?
Yeah, I think I need the practice use Python.
In this online course, right?
Yeah.
Okay, please send to me the link later. I will check. Okay.
Okay.
What else? I think if you have finished the basic online course, then I suggest you to start reading the overview papers for reinforcement learning, because now I think you have understanding about the algorithm, and next step for you is to read overview papers. So please remind me in the WeChat, even now you can remind me to send you 1 or 2 overview papers for reinforcement learning, not for applications, but for like general approaches and theory. Some parts I think you already understand and know, and no need to read, but some parts could be very important for you. I hope you could check it. And if you think that all these overview papers are already very clear for you, then we could start to read overview papers for multi-agent reinforcement learning. Because our direction is multi-agent, and but you can start multi-agent only if you finished single agent. Yes. So I think this is very great, and you are doing very nice. I'm very happy for it. But all these like overview papers only after the seminar at November, okay? In 15th of November. Now we just prepare for the seminar. No other things. Later we can continue like education and so on. Okay. Okay. Thank you very much. Thank you. Oh, very good.
Thank you.
Okay, next student is Li Juping. У нас
Да.
мы можем быстрее, потому что уже 2 часа прошло, но еще был студентов.
Да, конечно, все, я извиняюсь. Надо просто, ну да.
Да, 10 минут и плюс 5. OK。我给大家说一下，就是把报告控制在10分钟之内，然后我让 Onas 也快一点，因为今天现在连一半人还不到，所以还挺慢的。大家可以这样，因为15号那天的报告也是10分钟的，所以就按照这个时间区间来。好的，李旭平你来吧。
Hello. Hello everyone, can you see my screen?
Yes.
My name is Li Juping. I plan to learn the 5 parts of learning regressing and classification in open machine learning course molecules AI, and actually I learned the application of ordinary least squares, logical regress, and learning regression. My report is divided MDM reviews, reinforcement learning applications, model selection, resource for chosen reinforcement learning, squares decision problem logic, multi-sense joint optimization. One part analyze of MDM voice reviews. Now for a little parts, we have to solve the problem of binary classification of MDM voice reviews. We have a training set with marked reviews. One reviews marked as good, another 10,000, 2005 bad. And this is a big of a words model. This is how you get the answer. Tokenize. Build a dictionary overall DOCOM, spell multiply, and coding. Analyze of MDM with reviews. To get started, we actually download the dataset from the here and enrich it along with the rest of dataset in the data folder. Analyze of MDM with reviews, and this is the code. And this is the result. We analyze the number of documents in training data. Reinforcement learning applications. In the field of user recommendation, the time length of use is very strong. Analyze training in real time, and user preferences will also change over time. The current recommendations list can only get the current reward and cannot resolve this diminishing the problem. And in our group, I and the other people, we defend the link, and I made is underline recommendation. Model selection. In the issue of model selection, there are many different algorithms, Q-learning, deep network, and so on. Based on value functions, the Google DeepMind teams introduced the two components of the experience replay machine and target network that have been successful in deep Q network training into the abstract algorithm, which greatly improves the safety and convergence of model training, and was used in many complex continuous motor control tests that all have achieved very good results. Resource for choosing reinforcement learning. From the worldview, the user context sets in PGPV has an intertable causal relationship with the context status of their previous PVs and the behavior of the agent. Different shorting storage adopted by the agent in the same PV with make the search process move towards different directs of evaluation. Square's decision problem logic. Every time a user requests a PV, the agent makes a corresponding sort decision and displays the products to the user. Second, the user gives feedback signals such as click, page turning, and so on, according to the sort results of the agent. Third, the agent receives the feedback signal and make a new sorting decision when a new PV request falls. This process will continue until the user process and the product all extend the research. Multi-sense joint optimization. Due to the need for multi-sense switching, each sense is in a competitive relationship at the same time, and each subsense also has its own short strategy. So the overall strategy is each agent produces a short thread and at the same time does its own strange function, which makes its own state to a single action. The user interacts with the system scrutiny, so the behavior of the agent is also scrutiny. My report is over. Thank you, everyone.
Okay, thank you. Omnas?
Да.
Okay.
What I think, thank you for the report. I think now it's better for you to finish your education, focus less on the report, and help other guys for the overview and for algorithms and overview for applications. So you now need to work together, okay? With the other guys from reinforcement learning team. And I want you also, after when you finish, or sometimes to ask Sun Tzushi so that he will check if you did it correctly or not. But do not ask him to do a lot of things, because he needs to do some simulations for his research direction for his project. So he is very busy now. You can only ask him for some guidance, like check whether it's okay or not, and also you can ask me. So okay.
Okay, thank you.
Yeah, so at 15th of November, we will show, for reinforcement learning direction, we will show first the overview of algorithms and applications, and we will show the report of Sun Tzushi. Maybe other things for reinforcement learning no need to show, because we know we need to show some specific things. Like if you, and later if you will do some overview for multi-agent reinforcement learning, we can show it. And later on, if you do some interesting simulation for your scientific direction, we will also show it. Okay, so now when you almost finished your educational process, we need to now to focus on like overviews, and focus on later on focus on scientific project. Okay, so thank you very much. Thank you.
Thank you, Professor.
Mm-hmm.
Hello, Professor. Can you see my screen?
Yes.
Okay. Hello everyone. Good afternoon. This is my report about learning progress and applications of reinforcement learning. There are two parts of my reports. The first one is learning progress. It's about online courses, code, and further plan. second one is application of reinforcement learning. Reinforcement learning in gaming, robotics, and industrial automation. Applications in self-driving car, because I misunderstand what you mean, so I'm sorry. I just chose some part of applications. So this is the name of the courses.
Sorry, it's not a problem, you know, because what we are doing is we are adapting and thinking how to do and how to proceed with the seminar, how to continue with our work. So do not say sorry. It's okay. What we are doing is a research, right?
Okay.
We do not know
Thank you very much.
in advance what to do.
Okay. Thank you very much. And so this is the name of the courses I studied, and I learned about 70% of courses, then session control, variable, placeholder, what is action, activation function, add layer, build a neural network, plot result, optimizer in neural network, optimizer, accelerated neural network training, a good helper for visualization, TensorBoard, and so on. And second part, this is the code within written during my study. The first one is function fitting code. It can form an approximate quadratic function through continuous learning from scattered points and visualize it. This also. And the second one is neural network code. It can build a simple neural network, including the input layer, hidden layer, and the output layer, and visualize it. The input layer I said has 1 arrow, and the hidden layer has 10 arrows, and the output layer has 1 arrow. I use the ILU function as the activation function, and in the code I also generate and visualize the histograms of biases and white. So my first plan is to learn. My first plan is to learn the Riemann neural network courses and the DQN algorithm of reinforcement learning. The second part is application of reinforcement learning. We have witnessed some breakthrough in reinforcement learning, such as DeepQ network, AlphaGo, also including AlphaGo 0 and AlphaZero, and the DeepStack liberators. Each of them represents a large class of problems, and there will be a large number of applications. DeepQM represents a single-player game, or more generally, a single-agent control problem. AlphaGo represents a perfect zero-sum information game for 2 players. AlphaGo made remarkable achievements on the Go so hard question. AlphaGo is a milestone in artificial intelligence. AlphaGo makes general public realize the strength and the charm of artificial intelligence, especially reinforcement learning. And DeepStack liberators represents a 2-player imperfect information zero-sum game, which is also kind of difficult problem. It has also achieved artificial intelligence milestone level. So I want to briefly describe areas where IR has been applied. So first is reinforcement learning in games. Let's look at application in the game frontier, specifically AlphaGo Zero. Using reinforcement learning, AlphaGo Zero was able to learn the game of Go
Wait,
from square.
Sorry.
Okay.
Sorry. As I was saying, for applications, no need to read all this text. Just
I
on
know.
on the slides, just provide some key points, such as
Yes.
reinforcement learning was applied for AlphaGo. Then this is the text on the left. Then picture on the right with the picture of AlphaGo. Then you can below you can write who did this, like OpenAI did this, and what kind of environment. What is the paper where you can read about this? What is the and how to do it? That's it. No need too much information. DeepMind and all the other stuff. No need. Okay, you can just list. Okay. So let's go further. It's so I think you understand how to do it.
Yeah. I know. So
it's okay. Don't worry.
So do I need to continue?
Yes, but try to explain what I asked you. So briefly, where it was applied and how, if you have this information.
Yeah,
you remember where, how, why, where, why, and how.
Yeah. I will back it and to do that. So sorry, I think maybe I misunderstood what you mean, so I make it is wrong.
No
here
problem.
Is
Can you explain? Can you explain what? Can you explain what I have asked you? How I asked you, like robotics and industrial automation. Can you explain?
Explain what? Can you repeat?
Can you present these topics, but using the way I have asked you, like where it was applied and how and why? That's it.
Yeah.
No need too much details.
Yeah, I know what you mean. You mean we need to talk about what is reinforcement learning and application. Why in and why and what. I know what you mean, but I don't know
how.
why
and how.
Why and how. Yeah, I know what you mean, but I don't know how to express it.
Okay, no problem. Then please think about this. Actually, now no need to explain it. Now I think you understand what to do. But please do it all together with the other guys. Help each other, check each other, and improve each other. No need to. Yeah. So if you finish some part, you please send to the other guys so that they will look and say, okay, this is not very clear. Like, help each other, please, before sending to the join. Okay.
Okay. We will work together.
Okay. Yeah, it's very important. You are one team. You should because now you have one task. One task is to study together applications and do the presentation overview for the seminar. It's a task not for one person, for all of us, right?
Okay. Yeah. Thank you.
Okay, thank you very much. Okay. And I think the topics that you have chosen are very good. So all of these topics, of course, should go to the. But please add trading. Trading is also very cool. It's very applicable.
Okay. Thank you.
Yeah, don't forget to add links to the papers, links to the environments if they have open source environment. For example, environment for robots.
Yeah, I have a question. So we added a link in the last page. It right?
I would, it's okay, but better to add it directly to the application, like where you have found it, because it's easier for people to to find directly, if that's okay.
You mean we should put the line in the slide which is application?
Yes.
Okay,
Yes.
thank you. I know.
But I don't know how. But you should know how to make smaller text, like, because link cannot be half page.
Okay.
Use short, like very short.
Okay.
Very small letters. Oh, okay. Thank you very much. Who is next?
Thank
Who
you.
is next?
Thank you.
谢谢。
Next，刘秀秀，你来吧，你把你的说完。
好的。
Explain the AI 이 조리 последний через нее.
Окей. Она знает, что ей надо помочь ей сделать overview, да? Она тоже stochastic gradient descent рассказывает.
Да. 他刚才说的这个让你和张雨绮合作的，你知道吗？
我不知道啊。
那会儿他没在学长。
不在。
那会儿说的是马瑞敏，我好像在。
行，你回头跟马瑞敏说一下，然后和张雨绮一起学习。
好。
Окей, все в порядке.
Окей. Ладно, у нас не так много времени. Она может быстро пролистать просто слайды. Мы знаем, что такое стохастический градиент.
他说你做这个东西我们都熟悉，你可以不用讲，直接给我们看幻灯片就可以。就是让我们看幻灯片，因为我们都
看到吗？
看得到。
Можно быстро.
你可以快点把幻灯片展示一下，因为我们都知道这个。
好 ，OK。
No problem. It's just we have listened already this like this presentation. So I want you to answer about your progress, and I want to tell you that I want you to help UE to prepare some overview before the seminar at November 15 to help UE. She knows what to do. You need to help, and this way you will learn what is explainable AI. And but I want you before the end of this year to finish like educational part for online courses for machine learning, deep learning, and in 1 month you should seriously start to work on the overview for explainable AI. So of course you will listen some of the approaches, but you need to know other approaches as well. It's a study. You need to study this, and then we can also start some scientific projects, because now we change what we do, because you almost finished your educational part. Now we need to start doing overview for our scientific direction, and then we need to start working on something, and that's a key point. So I want you to help on this week to help UE, and then to finish your educational part, and then we can start working. Okay. So you can just show briefly. No need to explain. I know what is stochastic gradient descent. I think other guys have listened already this presentation, so maybe you could skip some. Just show in 1 minute. Okay.
Okay. Thank you. 3 parts. Introduction, SJD, and example.
Okay.
And it's
okay. It's clear. All this is clear. It's clear. No need to show. Okay. Clear. For future, too much text on the slide. It's very hard to read. Okay. It's clear. It's okay. Okay, I understand.
thank you.
Okay. Okay, it's clear. So please help UE. She will know what to do.
Okay. I know. Thank you.
Thank you.
OK，王泽阳。
Hello, Professor. Yeah. Okay. Let me show my.
Hello,
Can you see
hello.
my screen? Hello?
Yes, yes, hello.
Yeah. Yeah, because we discussed until the Wednesday. So before Wednesday, what I did is I read the reference about Nash-Bardeen solution and try to apply it in our model in the continuous updating. And third, and you asked me to read some reference about Chi9 because maybe the Nash-Bardeen solution it can't work in our continuous updating. And the third is under some Python codes. So after the Wednesdays, this noise I have already showed you. So in these 2 days, I just find some kind of reference like these two. But I think maybe it's more difficult to apply in the Nash-Bardeen solutions. I found I'm sorry. I found these articles. It's just implementing the Chi9 Bardeen solution, and found these articles. But I think it's very difficult to apply it because it uses probability, and or maybe I'm not very figure out it.
Okay, but do you know the general formula how to do it?
Yes, I know. It's like housing. We need to the maximum point which maintains the ratios of the gains. Yeah. So
Okay.
actually,
Okay,
yeah.
but please. So I will try today to think how to apply it and whether it is possible to apply or not. So
yeah, and this articles also is about the implementary. It's just about the non-cooperatives. It's and I can't find the very suitable references. It's maybe I'm not very clearly. I don't know the reason, but these 2 days I just found the Chi9 solutions and try to apply it.
Okay, we will think about this next week. So no need to present this during the seminar, the seminar. No need. Okay. What next?
Next is I try to complete my previous paper because we still have something to do, but actually I read that times we want to make our weight alpha. It's more how to say more random or just because at first we fixed our alpha, and I also want to in the general the time consistency to consider about it. It's also my problems.
Yes. So if you remember, you had several suggestions. For example, to apply PDP, like payoff distribution procedure, and to apply to make so that weights are changing in time, and then to study whether it is better than weights are constant. So you need to you need to have some ideas like why you need PDP and how to make it. I think you can use the thinking that we had in our P1 paper in our paper from the first quantile you remember there we use some imputations and some like we were calculating the imputation distribution procedure for each imputation, right? You remember? And then combining the imputation vectors in the game, in the overall game. So you can think of the PDP procedure for your case for non-transferable utility game as a kind of similar thing. So but you need to understand how to do it and why you need to do it. It's the first thing. Second thing, about the question, why and should we have weights that depend on time? It's a question you need to have some idea in mind, such as maybe you can consider like think of some real life example, because you build some mathematical model. When you build mathematical model, you need to keep in mind some real problem or something, yes, to take inspiration and idea. So you can think when changing weights is suitable or not in the real life, and then try to use this idea in this because you need some key point, like core idea, like like continuous updating approach comes from idea. You remember that assumptions?
Yes, I remember.
It's idea. You need to have idea in mind. Then you can build some mathematical model around this idea. So you understand what is a non-transferable utility game. What is the key point of this game, right? So you can think of the you know what is the application, right? But you can think of the you can think why it is important, like why you should be willing to reconsider weights, okay, before we have a discussion, okay?
You means if we change the weights, how will be happen or something else?
Yes, you need to consider real life process, such as you have for example 2 companies, they think they try to negotiate of what they will do next, and you can think, why would they want to change weight? Why? If they already agreed on weight, why would they want? You need to have some real life idea in mind.
Okay.
Why they want to change, why they don't want to change. Then from this idea you can construct some mathematical formula. You know?
No, but we use Pareto optimal and set in the weights is in order to maximize every player's total payoff, maximize the total payoff in the weights. But it's our main idea.
No, this is not idea. This is a model. Idea is to idea is another thing. Idea comes from the real life. The idea of all this theory is to construct the mathematical model of a process where agents cooperate but cannot distribute their reward or payoff.
Okay,
So,
you means I need to apply it in real life.
Not apply, think. You need to think about this as a real life, yes, and think what will happen in the real life. No need to read papers about this. Think. You need to understand why. What means choose weights? Choose weights means to you know, we sign a contract and we try to negotiate, and we have negotiated, and we think that we should choose a Pareto optimal outcome where I have weight like 0.7 and you have weight like 0.4. Why? Because maybe like first company is more important and he's stronger, yes. But it is but maybe another company will want to reconsider his weight at some point. Maybe another company will come stronger and can make more influence. It wants to reconsider. And if another company wants to reconsider his weight, what the other company will do? Maybe the other company also want to reconsider his weight, and so on. So it's a crazy process. So you need to understand what is a good way to do it. When this process is consistent, when you need to have this thinking of real process, okay? Do not think formulas now. Formulas comes from process, okay? You understand?
Understand. Thank you.
So kind of, you need to have maybe it's also intuition. You need to have some intuition of what is going on. Okay.
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 Okay. And
okay.
another
Then
thing.
then after this, we can directly decide what can be done, how we could change weights, what means to optimal changing weights, or how to use this PDP in here, why we need to use PDP. Everything comes from the real life, from some thinking. Okay. So
we need to prepare the presentation until the 15th November or not? Because I don't think this my presentation could show until the seminar. So if I need to prepare or not.
I think this presentation maybe no need to show directly. Yes, but anyway, we will need next week to discuss with you again this. But maybe I will think maybe you could present your current results shortly, because it's your direction, and maybe people should know your direction. Maybe you cannot present new things, but you can present what you have done already, is also very good. Okay.
Yes. I will prepare.
No need to prepare. We will think about this. But for now, focus please on your current direction. Okay. We will contact next week, and we'll think. Okay. Thank you very much. Let's continue.
Okay, thank you.
Okay, thank you. Thank you, Wang Ziyang. And the next student is Ye Peichen.
Yes, I'm here.
Hello.
Hello, Professor. Can you see my screen?
Yes.
Okay. Hello, everyone. Welcome to my presentation. My name is Ye Peichen. What I want to report today is an article about Li, the dynamic machine banking solution for two-stage cost-sharing games. And I will introduce this article from the following 5 parts. The first part is the introduction. In the paper, two-stage network games are considered in which at the first stage players simultaneously choose their behaviors, whereas the game proceeds to the second stage with probability, which depends on strategies of players choose on stage 1. In each stage, a minimal cost spending tree game is played. In a cooperative case, as a solution, the dynamic nation banking solution is proposed, and the ceremony is approved to allow the dynamic nation banking solution to become consistent. The second part is a description of the game. Firstly, give some basic knowledge, such as game tree, set of vertex, set of players, source, draft act. Some related definitions are given next. They are the cost matrix C. It is a n +1 by n plus 1 matrix. In the paper, Ci0 is equal to C0i. It is a non-negative consistent. The definition tool is the strategy Xi. Here use the Xij donate a strategy of player I against player J. This is the cost of the edges Cij and the minimal cost spinning tree. It means the value of Ij when Cij researches its minimal value, and the total cost of edges of minimal cost spinning tree. Next, we describe the process of the game. In the first stage, players choose their behaviors at the same time to form an n-dimensional strategy profiles. For example, consider a set of 5 players in the game. Figure 1 and Figure 2 show different cost spinning trees contrasted by players in the game by choosing different profiles of strategies. And we can know this is Figure 1. We can get the all strategies of all players, and this is their strategies. And we can get the edges they formed. And then calculate the minimal cost spinning tree and total cost of edges in the minimal cost spinning tree. Different cost spinning trees will affect transition probabilities P, and there is a P, and different results will be obtained in the second stage of the game, as shown in Figure 3. Assuming that the strategy X1 is selected in the first stage, there will be different transition probabilities in the second stage. This P means that the probability of the game moving from the initial vertex Z1 to Zk, and the probability of moving from Z1 to each vertex is equal to 1. Then give a alpha matrix. This is a definition. There alpha IR is equal to alpha IJ. It can choose one or positive infinity. Here use the method of Hadamard product to give the cost matrix of the stage game in the vertex Zk. This is the Hadamard product. By this, get the cost matrix of the stage game in the vertex Zk. It is equal to alpha matrix multiply cost matrix. Next, consider the cooperative behavior of players in the game. In the two-stage minimal cost spinning tree game, it is assumed that the total cost of players in the game is the sum of the cost of players in the two stages. Here the stages X point are called the cooperative strategies. This is the game values of players in the game gamma Z1. The value of the game for the player I is identified as the value of the zero-sum game in which player I plays against players from the set except himself. In the zero-sum game, all players in set N except I don't want to be connected to the source. Thus, in this situation, assuming that players in N except I are out and the minimal cost spinning tree contains only one edge, I0 is only one edge, which means that the cost of this unique edge in each stage game is the cost of minimal cost spinning tree of this stage. Then the game values of players in the game gamma z2. Suppose that the subgame gamma zk happened in the vertex zk of the tree-like giraffe H. Thus, the cooperative solution of the subgame for the set at the second stage, it benefit as follows. In a similar way, the value of the game for the player I is identified as this is equal to CI0. The first part presents the dynamic Nash Bayesian solution of the game. Let the vectors hz1 be cost vertex in the game gamma z1. The set of all possible costs is identified as S1, and the value of the game for each player is equal to 2 times CI0. Here, S1 is the Bayesian set, and V is the disagreement point. And then give the Nash Bayesian solution. At the second stage, the set of all possible costs is identified as Sk, and the Nash Bayesian solution in one stage minimal cost spinning tree game is identified as this. In the theory of dynamic cooperative games, time consistency of a solution is the key problem. Here, the imputation distribution procedure is used to construct a dynamic Nash Bayesian solution. But sometimes in two-stage minimal cost spinning tree games, the imputation distribution procedure beta may take negative value. So this paper proposes a new theorem to that makes dynamic Nash Bayesian solution satisfy time consistency. This is a theorem. That's all my report. And recently, I'm reading some articles related to two-stage network games, which is very interesting. I want to have more in-depth research in this area in the future. That's all. Thank you for listening.
Okay, thank you. Ovnas?
Thank you. Thank you. У меня вопрос на русском, можно к тебе?
Можно? Да, ну, ко мне, пожалуйста.
Да. Как ты думаешь, вот эти ребята, они должны, вот что им рассказать 15 ноября? Им рассказать одну презентацию вместе или несколько? Как лучше?
По теории игры?
Да.
Пока я думаю, либо вместе, либо разные. Но если они не могут самостоятельно хорошо готовить, лучше вместе. Вчера у нас было собрание. Я с ними обсудил, как готовить к семинару. Но по-моему, это доклад не так хорошо, потому что она не так просто анализ статей от меня. Ну, скучно тоже.
Да, но нет, это главное, что она выучила, это хорошо.
Да.
Но
может
быть, они сделают вот так тоже overview пока?
Можно, но я боюсь, они могут.
Если у них нет конкретного результата, лучше overview или как? Или как считаешь?
Хорошо, я скажу.
Нет, я тебя спрашиваю, это ты же главный тут.
Да, я понимаю, но раньше я тоже так хотел. Я боюсь, что они не могут, это трудно, overview. Ну, попробуем. И наверное, это лучше, чем настоящая работа.
Но не надо так много, полчаса они не смогут, конечно, обзор сделать.
Конечно. Вот эта презентация для конференции GTM, поэтому это полчаса. Это только.
Да, окей.
Окей. Еще другая
Так это
девка.
твоя работа же, да? Это твоя, да,
Да,
твоя
это моя
статья?
работа. Они сейчас
А,
читают
окей.
статьи от меня и от Леры Свеча.
Мгм.
Поэтому
А по другим? А ты же сказал, что они хотят сделать overview по cost spanning tree, нет? Или или как?
они не сказали. Это я сказал.
Ну, да, но они не читают их пока или читают?
Они читают, уже читал статьи в течение 5 лет назад. Ну, 5 лет назад статьи некоторые.
Не, они, не ты.
Да,
Не
да.
ты, они.
Они читают.
Ну, хорошо. Ну, ладно, ну давай потом обсудим, хорошо?
Хорошо,
Я пока не
пойдем.
знаю, как лучше.
Хорошо, потом я скажу тебе.
У Ван тоже я не знаю, как лучше, понимаешь?
Да.
Но хотя бы я понял, что можно показать то, что она сделала раньше. Тоже
Да.
ничего.
Да, я понимаю.
Может быть, ты расскажешь просто, что ты сделал, и все?
По минимуму хоспенче я могу сам
Да.
скажу им.
Или они расскажут, что ты сделал. И все. Так тоже
Посмотрим.
можно.
Посмотрим.
Окей, все.
Окей. Хорошо, так, ну, thank you for your
Thank
report.
you.
And the next student, please prepare your presentation.
Thank you.
学长，下一个是我吗？
是的，下一个是你。
哦，那还有那个周江静学姐，她不是还没有？
哦，对，我忘了说了，周江静，是那个他，周江静，因为特殊情况嘛，他随后给我们做。
哦，
这次不做，今天不做，你就做就行了，
Hello everyone. Today I will introduce the two-stage net game and give a report from the following 3 points. First, it is my study list. I read 4 papers about two-stage network game and minimal cost spanning tree game. Next, I will talk about the paper two-stage network game. At the first stage, the players form a network, and at the second stage, the players choose their strategies. But it has 2 situations. One is cooperative game, and the other is it's a non-cooperative game. At the first stage, the player chooses strategy and form a network like this. In this picture, it has 4 persons, so the player set n equals 1, 2, 3, 4. Because player 1 and player 2 have a double arrow, so that means the link between them has formed. So we can know if Jij equals JJI equals 1, the link Ij is established. Otherwise, it equals 0. For example, J34 equals 0 because player 3 didn't connect player 4. We can say this network contains edges 1, 2, and 3, and 2, 4. So we get the first stage network J. Then we go to the second stage of the game. This is a description of some symbols, such as the payoff function, the second stage strategy, and so on. And at the second stage, player may break the exciting links which established at the first stage. So we will get a new network, JD. There are 2 situations in the second stage. One is non-cooperative game. In this situation, players choose their strategy independently. The other is cooperation between players. In this situation, they choose their strategies jointly. It is a normal form of the non-cooperative two-stage game. In order to solve the problem of the solution to this game, we can use the Nash equilibrium like this. Now let's use another method to solve this problem. It's cooperation at the second stage. It's cooperation between players. There are some important theorems and definition about this part. We can also get a norm form in this game and use the Nash equilibrium to solve the problem too. But it's a little different from non-cooperative games. Now consider a two-stage network game that is different from what I just described. In this game, player can choose their strategies at all stages. Here is a theorem about characteristic function in this cooperative two-stage network game. We still use the Shapley value to calculate the payoff due to each player in the correlation. Because the Shapley value doesn't satisfy the time consistency property. To solve this problem, we introduce the imputation distribution procedure to ensure that each player in the game can get the reasonable and the maximal payoff. That's all. Thank you.
Okay, thank you. Omnas? Hello?
Thank you very much. Thank you.
Okay.
Да.
Да. Я потом я с ними обсудить, как готовить докладу.
Конечно.
Да, по-моему, они должны вместе и делать overview.
Да, и я согласен. Тогда всем очень интересно и очень рады.
Скучно, да, скучно. Okay. Thank you, Chenmin.
Thank you. Very good presentation.
我们应该结束了吧？陈明，你是最后一个吗？
是，我是最后一个。
Anna Baslitna.
Okay. Okay, thank you very much, everyone. No. Как не может быть последняя? Нет.
Кто еще?
So, are you there?
Yes.
No, not Ting. Yes. So, Ting and Feiran. So, what do you think? What you will be able to present at 15th of November?
Me with Feiran still on processing for the clustering, and now we have some problems. We automatically divide different groups, and almost of them will be automatically allocated in one group. So it means the size problem still not solved now. Feiran and I try to solving this problem.
So I want to say that for the reinforcement learning direction, we have now like the presentation will be like this. First, there will be an overview of all methods and algorithms, applications in the real world, and so on. And then the current results of Sun Tzu Shi in the project for scheduling. But for explainable AI, now we have very good overview, but we need to show some specific results to show that we not only do some overview, but some work on the direction. So what do you think? Will we be able to present something for like your sampling method and for bi-level method or not for cancer data?
If in 15, I think it is okay. Time it is okay. Feiran and I will obtain the results, I think.
Okay.
Who will do the presentation to show the results? We are all combined in UE presentation?
I think UE will do presentation for overview, and you can combine with Feiran, and maybe some other guys could help you to make a presentation about you can call it like large scale, large dimension explainable AI approach. And if you could present 2 different methods for one specific Hansard data set, and show the difference, that would be great.
Okay, I think now we have 2 problems, and first from the bi-level approach, and the next part I also try to check with you. Maybe I share the screen. Do you have time now?
Yes, of course. I think we finished the main part. So, but also I think there is presentation from 1 second. Ginger, do you want to show something or ask something?
Yes, do you ask me?
Yes, you want to present something, right? Or you want to ask something?
No.
Okay. Okay, no problem. So what do you think? Maybe let's decide. Do you want to try to present something on 15th November, or better to wait next month and to present next month?
In next week I will.
Next week you want?
Yeah.
Okay, because next week there will be not only me, as you know, a lot of other universities.
I know this, yes.
But we need to, if you want to present, we need to think directly whether what you want to present is kind of finished and so on. So, so we need to discuss it. When do you want to discuss it so that we are sure?
Next week, before the next Sunday, I will prepare the PowerPoint in advance, and I will send it to you to see if it is okay.
Okay, but PowerPoint is not the most important thing, but right, because we still need to finish this Bayesian updating approach, and for the continuous updating, and we need to first let's have a discussion about this, okay?
Yeah.
So first let's discuss the example model that you wanted to show, and maybe you could send me some photos and we can discuss this in WeChat at Tuesday maybe. And if it's okay, if everything is okay, then let's start with presentation. But if something is not okay, no need to do presentation. It's a waste of time. Okay, let's.
Okay, I have calculated the Nash equilibrium, and I can send the picture to you. Yes.
Oh. When have you sent the picture?
I will in a few moments. I can send it immediately.
Okay. So let me first discuss with Atin and Feiran, and then I will get back to you. Okay.
Okay.
Okay. Thank you.
When you are available, you can tell me, and I can.
Just do not quit. Do not quit the meeting, and we will continue.
Okay.
Okay. Thank you. Oh, Atin, yes. Sorry. Can you please share the screen?
Okay, wait a second. Let me find the resource.
我们看 sẽ значит еще будет доклад Zhou and Feiran.
No, we don't have
мы сейчас
доклад.
подумаем. Да. На самом деле, извини, Инь, мы уже на самом деле основную часть закончили. Если кто хочет, может выходить. Не обязательно так слушать, если им только интересно.
Да, я скажу им. 我们整体的报告已经结束了，如果有事儿的话，或者是累的话，可以去退出去休息了。现在就这样。
好的，好的。
Yes, thank you very much, everyone. Thank you, thank you. Okay, team. Please continue. Please continue.
Hi, Agnes. And now actually we using the aggregative clustering, and the results you could see in here. This is 30 features, and most of them are located in one group. So we now considering how to solve this problem.
Okay. But about metrics, what kind of metric do you use? And
we using almost the same as the GPON project, and here you see we calculate the standard. Wait a second. Wait a second, Firan. Maybe you could explain here how you calculate the matrix here.
Okay.
I have just sorry. I have just one question. Do you use Fourier transform or wavelet transform, something like this?
Использовал вот FRT by X это матрица, которая данные уже сделали Fourier transform.
Окей.
И с этой матрицей мы стали матрица на расстояние.
Окей, это очень хорошо. Хорошо. Я понял. Значит, я подозревал, что будет проблема с кластеринг. Я так и думал. Да? Поэтому мне надо чуть-чуть подумать. Сейчас, если мы выберем хороший метод для кластеринга, мы сразу получим результат, который мы хотели, правильно? Надо... Ага. Да. Вот это last step, это просто last step, который нужно сделать. Дайте мне немножко времени, я постараюсь сегодня подумать, потому что нам нужен кластеринг. Значит, есть, допустим, алгоритм K-means, правильно? K-means мы делаем ровно K-clusters, правильно? Есть кластеринг algorithms, где automatic number of clusters, да? Есть DB-scan, где вы определяете epsilon. Но у нас другое target. Нам нужно, чтобы у нас было в каждом кластере максимум, сколько вы хотите, 5 или 7 элементов.
Не больше, чем 7.
Да, это я не знаю такой кластеринг метод. Вот, это проблема, поэтому мне надо подумать, есть ли такие специальные методы, которые могут кластер только, допустим, это совсем другая вещь, чем K-means. Это совершенно другой смысл у этого метода. Вот. Поэтому мне надо подумать, как это сделать немножко. Давайте я сегодня попробую подумать.
And also one information I talked with Firan, and wait a second. We have such data set, right? And you could see from 0 to 10, it's all about mean value for different features. All about the mean value. And then from the 10th to 20, and it's all about the error. So the feature is same, but different KPI things. Mean value, error value, and from 20 to 30, it's about the worst radius. You could see the feature seems totally all consist of 10, and they has the KPI of main, worst, and error. So I just considering if we first step by hand divide into three groups, and then we using clustering methods for each group, we again do some automatically clustering. I'm not sure it is so good or not. But it's most easy way to handle this problem.
I know, I know. It's actually very good approach. It would be perfect if you, for example, do it like this. You present the data, you show in the presentation the data, and then you say we have two methods like sampling and bilevel method for this data, and you present results for sampling. Then you present for bilevel, and you say that in bilevel we need to use some clustering. So first thing we did is we clustered features according to the meaning. Yes, is what you're saying. And then we used mathematical clustering methods, and then you compare these results. Then you could say that, for example, our automatic approach is not worse than approach like manual. It's not worse, maybe even better. You know, it would be perfect. It's a kind of perfect way to show your results, to compare the because when you show some clustering results, no one understands why it should be one cluster. But you here present both things. It's very good idea, actually. It's very good. It's very good. but better to use both. Like if you use only one way, it's not so not so good.
And by the way, how to compare the final results? Actually, sampling I think could very quickly to implement it. And but for example, we already obtained the results for clustering, sampling, and original. Now, how to compare result to show which one is better from the time or from what?
Time is one thing, but another thing is that we did not solve yet. We need to discuss it with you still. It's an open question for me as well.
Okay. I got it.
If your time is limited, you want my help to search for it, I can try to do some searching. And
Okay, I will with Firan to try to solve it today. If not, then maybe tomorrow we'll tell you and ask you for help.
Yeah, but for clustering, anyway, for clustering, I need to help you. So please do not spend time for choosing other clustering algorithm. If you don't know which to choose, do not spend your time now. I will spend my time. But for KPI, for explain, I hope that you could, by yourself, you could think about this, because it's your main direction, right? So
yes.
So if, for example, you can think today about this, if you do not have an idea, then we can have very serious discussion at Tuesday or better at Tuesday, of course. And then we can decide. We just need, so I can give a lot of ideas, but you need to have a proper discussion with me. Then I can generate good ideas. Okay.
Okay, no problem.
Yeah. Okay, I think it's very great, very interesting. So now all this, so now you can give the Shapley value for each clustering, right? Each.
If not automatically, we could give the results, but you could see here still problem with the large size.
I know.
Yeah, but anyhow, we already able to calculate it. Already could obtain the results.
That's great. That's great. Thank you very much, guys. Thank you. How about sampling? Sampling.
Sampling, I will also finish it today because I spent some time from the clustering with Firan.
Okay.
But sampling is not hard code already ready, and today I will combine code to get the results.
Maybe Firan could help you, no? Or it's hard for him?
It's okay. It's not hard. Just because code I already all right and just use it, and then we could obtain the results. No difficulties in this part.
Okay, I think. Are you satisfied with these results. Do you like this, or you have some like
no, because now I just thinking for how to solving these problems. No,
yeah. For this kind of things, you have me to help. So
Okay.
I will take this for me. Okay.
Okay, then I will try to obtain all results and consider how to compare them.
Okay, I think this is great. I think our all of our presentations will be very great, and everyone will like this, because we have first we have great overview, and then we have very good and interesting results for explainable, for enforcement, for game theory as well. So it will be very interesting.
Okay,
Yes.
thank you.
Okay, thank you. What else? Okay, I think no urgent things. For teaching practice. So
okay.
Did you read my did you read my email or not?
Not yet, because I just wake up in the morning when
Okay, no problem.
you call me to attend this meeting. Sorry, I will check it later.
Please join to the WeChat group, because I understood that for a long time you and Feiran were not in that WeChat group, so you did not know for this meeting today. I'm sorry. And please, который for in WeChat.
Я могу пригласить. Какой группу
Okay.
они должны?
Explainable.
Explainable AI, Feiran and Zhou? Okay.
Спасибо.
Пожалуйста.
Just check my email. Maybe no need to check today, because it's a very long email and you need to think it through. Maybe at Tuesday or Thursday we could discuss it. Now no need to check.
Okay, thank you.
Okay.
And by the way, Feiran, here has some simple methods to check the clustering results. Maybe not just changing the parameters, average, complete, word, single. Maybe you could check it and to see if results could be better.
Okay, I will check it.
I send you a link, and this is what I can do for now. And next step maybe if results still no good, then maybe we need Avanes help us for this part.
I will help. No problem.
Okay.
It's my job. Okay. Thank you very much. Thank you. Да.
А может еще вопрос?
Да.
Мне кажется, может быть, в данные уже есть такая проблема, что они все очень близкие. То есть, может быть, я просто так сказал, может быть, кластер не может выдать нам хороший результат. Может быть. Пока я не думаю, я просто попробовала 2 либо 3 разные кластера, но результат не так хороший.
Я понял. Ну смотри, ты помнишь, зачем мы это делаем? Мы хотим, мы такие хотим кластеры, чтобы точность explain была выше. То есть, но, конечно, если мы не можем сделать, если optimal clusters это такие кластеры, когда мы не можем посчитать, очень computational complexity очень большой, то тогда, конечно, надо делать чуть-чуть менее оптимальные. Поэтому я и хочу сделать алгоритм кластеризации, когда у нас мы говорим, что не может быть больше, чем 7 elements in the cluster. Тогда, может быть, explain будет не такой хороший, потому что некоторые фичи, которые должны в одном кластере, в разных. Но при этом мы можем посчитать, понимаешь? То есть, поэтому надо именно такой clustering метод. Я сейчас буду думать, окей? Я сейчас сделаю. У нас нет, у меня нет другого выбора. I don't have any other choice.
Спасибо.
Окей. Спасибо вам. Очень хорошо, очень весело. Спасибо большое.
Okay, so let's finish our scenario today.
Не-не-не, Инь, на самом деле больше никто, все остальные могут выйти. Я хочу поговорить с Джинджер.
Джинджер это кто?
Ну, так в чате.
Ее зовут Jiang Jing. Не Джинджер.
Я знаю, но почему в WeChat написано Ginger?
Ginger?
Yeah. 我的微信名是那个 Ginger。
我在说Ginger。
Зачем в WeChat Ginger? Я не знаю, как имя.
Nickname, наверное. Okay, so if our seminar is over, I will have a lunch. So.
Okay, I also want to have lunch, but I will have later. Thank.
Okay.
Okay, thank you. I'm also leaving. Thank you.
Okay, thank you. Thank you, Lee. Thank you. Thank you. Ginger, can you change your name in WeChat, or I don't know how to do it?
Okay, I will.
Or no need. Because I do not, I only communicate with you using WeChat. So usually in WeChat. So it's very hard for me to sometimes to call.
Ginger is okay.
Okay.
So this is the example that we discussed, and I put this in. This is what I showed to you yesterday. This part, and then I write the payoff function for the player I. This part is for the whole game from T0 to the capital T, and this part is for the sub game. I don't know if it will be used, but I just write it like this. And then in order to solve the problem, I write the value function WITX and W minus ITX satisfying the following equation. And it's the Bellman equation. WITX, it should be maxi UI, and this part is from here. And plus R is our discount factor. And R times WI star T plus 1. And this part is XT plus 1. XT plus 1 we have already get here. And it's for the UI, so the sigma UI should divide it to UI plus which G is not equal to I. So it's this part. And the condition is WI capital TX is equal to 0. This is for the value function. And the next step, in order to solve this, I assume that WITX is equal to AIX plus BI. AI and BI here I suppose is a constant, and then I get AI is also the constant. So the suppose is correct. And then by using this method, I can get AI and BI. And this is a formal way to solve the problem.
Wait. So UI depends on the observation.
Yeah, depends on the observation eta.
So and observation theta can change in time, right?
Yes, for different period t, it's different.
And
it depends on the time